Hey guys, so I couldn't let good be good enough, and truth be told, I did a lot more flow testing, and no matter what I did, this outside runner, it flows a lot more air than the one that we've been trying to improve this whole time. So I'm gonna have distribution issues. The other issue is 1843657 firing order. So correction on my last video, I was looking at the manifold backwards. After I rewatched part of it, I was like, oh, idiot. So this is 5 and 7. Okay, so these fire together. So now we have other issues, but we want to make them all the same. But at the same time, it's very important that they flow as similar as they can. So it's not that now I'm chasing CFM, I'm more chasing distribution. I want to make sure that if both runners flow the same amount of air, I have the best chance of number 7 not stealing from number 5. 5 fires first, however, but the way that the overlap works and with the timing of the camshafts, there's going to be a chance that number 7 will rob from number 5. So I think it's very important that we address that issue. The other thing is, like I said, 18436, okay, that's this one, okay. What's right next to number 6? The closest port is number 7. So this is going to draw first. The air is already going to be moving in that direction, and then you have a pulse, which is closer to number 7, and then 5, even though 5 is before 7, that pulse, it takes a lot of calculation to try and estimate it, but it can pull air-fuel mixture away from 5. So I don't think we'll be able to get it to flow more than 7. I want it to be as close to number 7 flow-wise as possible. Distribution is very important, guys. You gotta get fuel distribution. And if you were to run this thing, look down that runner, okay? So I'm gonna put my camera. This is where, all right, y'all see? This is exactly the angle of approach the air is gonna hit that port through the throttle body. All right, you've got a divider here. Okay, but do you see the runners? No. Now, same angle. You see the entire runner now on number 5. Okay, number 5, I have moved this wall. We now have a complete 15-degree layback. And I moved the recession a little bit, and the reason I did that, it looks like it's almost kind of like a upside down hockey stick on the wall there, and that's because I wanted to have a clean divider up here. Okay, I wanted this to have a nice clean divide line, because as the air is pulled through the throttle body and hits this roof, I want this to kind of shear those pulses as much as I can. Okay, and then the divider has been bludgeoned, basically flattened it out and then smoothened it to make sure it's not a knife edge, and there's a complete transition here. So I've got something coming tomorrow, and you probably won't get to see it tomorrow, but maybe you can, we'll see. I'm gonna do several different, I hit the button. I'm doing a test tomorrow. I've got some stuff coming in the mail that I think you're gonna enjoy. I think it'll be an interesting test, one I have never done before, back to back to back. So wait for that. I'll tell you about it whenever the video comes out. But for now, we're gonna flow 5 and 7. And see how close they are in flow after all the new changes, and I'll get back to you. Alright, real quick, before we do the flow test, I wanted to show you what that transition now looks like. So, you can see down in the ports, we're coming back up to the roof. Sorry, my camera got hung up on something. Alright, you see the throttle blades? This is the throttle bore. Okay. And right here, you can see how there's a little lip. That's the gasket, which I have underhung slightly, because that little transition there from the throttle bore there to that lip, that gasket is undercut from the throttle bore, so it does not impede flow at all. That air is going to come around that transition. Sorry, I moved the camera. I was trying to see where I had this thing. Okay, it's going to come down the throttle bore there and make that turn down the roof of the port. Okay, so you can see that's under. See it? So that's on purpose. I want to make sure I make that clear, as you want that out of the way. You don't want your gasket to get in the way of airflow at the bottom of your throttle plate. Okay. And this is what it did look like. Let me move the camera on the other side. Sorry. So if you're looking here, I've already underhung the gasket here. But if you look at that wall, it runs right into that wall. That's shrouding the air and speeding it up and making it come down and hit that wall, or that floor. So compare that over here. To that. Very, very different. Whoop! Let's see what that does for flow. Hey guys, so some interesting results. So let's get to it. Alright, so this is number 7 cylinder, number 5. So if you remember, number 7 on this outside flowed more before than the inside runner. Well, no difference there. But the interesting is the curve in which they improved. So all the changes I've made. So let's start with number 7. It didn't gain anything at 2. Lost 1 at 3, which is nothing. Lost 6 at 4, which is a little something. I didn't measure 450 thousandths lift on number 7. So I don't have that to compare it to. 5. We gained 10 CFM there. So if you're wondering, this is what I'm comparing this to. This is number 7. This is number 5. Okay, so we're looking at 7 first. So at 500 thousandths, it picked up 10. At 550, it picked up 23, which is huge. We're flowing 306 CFM on that at 550 thousandths lift, which is amazing. Far beyond what I was expecting to be able to flow. 275 average was what I was really hoping for at the high lift, and we're at that at 450. Didn't quite get there here, but we'll talk about that. So 500, 550, and then 600 we picked up 16, and 650 we picked up 12 CFM. So we picked up peak lift. Pretty much did not impact the low lift flow much at all. I don't know what 450 was, but it picked up a ton of peak lift CFM. Swapping over to number 5, so number 7 picked up a ton of high lift flow, and number 7, and then number 5 picked up a bunch of low lift flow. So let's look at it. So at 5, and I'll zoom out just a little bit so you can see the before and afters here best I can. So at 200 we we lost 7, which is actually pretty significant. We gained 4 at 3. We gained 25 CFM at 400 thousandths lift. That's a ton. At 450, we picked up 21. That's a ton. At 5, we didn't really pick up anything. It was only additional 4. And then at 550, it was basically the same. 273 minus 1. And then at 6, we lost 4 CFM, and at 650, we lost 3 CFM. So I'm getting choked out a little bit earlier, but again, this is pretty much nothing. And again, my cam only goes to 592 thousandths lift. So the mid lift flow is all I care about, and we picked it all back up. It's freaking awesome. What's not freaking awesome is how different these 2 cylinders are. Now the good news is here in the mid lift area between 450 and 200 thousandths lift, there's not a huge difference there. You know, there's like 9 CFM more here. Let's see here. I'll just stop the video and do the math real quick. Okay, just to make this quicker for you guys. So what I care about here is absolute value. So this middle line is the difference, the delta CFM between 7 and 5. I don't really care which one's better or worse. I just care what this delta is. So at low lift, like I said, there's not a huge difference between 2 and 450 thousandths lift. I'm okay with that amount of difference. The big kicker here is between 5 and 650 thousandths lift. And again, 650 thousandths lift doesn't really matter for my cam. So let's go up here to this 27 number, but still, between 5 and 600 thousandths lift, peak flow is way down, way down. 33 CFM is astronomical. So I've got to look at this. Like I said, I've got something coming tomorrow, so stay tuned for that. They may make this do different things, like go up here, 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 just as an FYI. So you'll see what that looks like when I make that video, but we're going to see if those things will, if I can find one that'll fix that delta. Once again, I hit the wrong button. Tried to flip the camera and hit stop. Okay, I'm getting a ton of spacers. So we're going to flow test this thing with a bunch of different spacers. From cheap, and all of them are 4-hole tapered spacers, so I'm not getting any open spacers. They don't work. Let's just say they don't work for a single plane, in my opinion. They work really good for a dual plane. But a single plane, 4-hole taper spacer, I bought 4 of them. So we're going to test 2 different brand 1-inch spacers, a super cheap one and top dollar one. And then we're going to test a 2-inch spacer, which is going to be the top dollar one, the most expensive 2-inch spacer you can get, and then a kind of a middle, not the cheapest, but a middle ground, probably more the average guy willing to splurge on, but probably doesn't want to spend a ton of money on. If they don't come in packaging that I have to open up like vacuum seal, I'm going to test all 4 of them. Now, if they all come like that, I'm not paying for all of these things. I'm sending back what I don't want. So if I can get them out and test them without scratching them up, we're going to do that. Yeah, stay tuned for that. Hopefully that'll fix some of this high lift flow on number 5, but we'll see. Till next time.